Every black hole begins with the life and death of a star. Stars, like our own sun, are fueled by nuclear fusion, where hydrogen atoms fuse to form helium, releasing vast amounts of energy. This energy counteracts the star's own gravitational force, maintaining its size and brightness. But nothing lasts forever. When a massive star, at least 10 times the size of our sun, exhausts its nuclear fuel, gravity takes over. The outward pressure from fusion can no longer counterbalance the inward pull of gravity. What happens next is a catastrophic event, a supernova explosion. This explosion is one of the most energetic events in the universe, ejecting most of the star's material into space. What remains is the core. Depending on the size of the star, one of two things can happen. If the core's mass is less than about 3 times the mass of the sun, it will collapse into a neutron star. But if the core is even more massive, gravity wins completely. The core collapses into an infinitely small point known as a singularity, forming a black hole. This is known as a stellar black hole, and it's just one type in our vast universe. While black holes sound like the stuff of science fiction, their concept was actually predicted centuries ago. In 1783, British scientist John Michell first theorized about dark stars, objects so massive that not even light could escape their gravity. But the modern understanding of black holes began with Albert Einstein's theory of general relativity in 1915. His equations showed that space and time could bend under the influence of massive objects. Then, in 1916, German physicist Karl Schwarzschild solved Einstein's equations for a spherical mass, laying the mathematical foundation for black holes. Despite these early theories, it wasn't until the 1960s that black holes moved from theory to accepted science. The term black hole was coined in 1967 by physicist John Wheeler, and the first physical evidence came in 1971 with the discovery of Cygnus X1, a stellar black hole in our galaxy. Not all black holes are formed from dying stars. In the centers of most galaxies, including our own Milky Way, there lies a supermassive black hole, millions to billions of times more massive than the Sun. But how did these giants form? While stellar black holes form from individual stars, supermassive black holes are thought to form during the early stages of galaxy formation. It's believed that huge clouds of gas collapsed under gravity to form these massive objects, or that smaller black holes merged over time to form the behemoths we see today. The defining feature of a black hole is the event horizon, the boundary beyond which nothing can escape. Once something crosses this point, even light is pulled into the singularity. The closer you get to the event horizon, the more intense the warping of space-time becomes. Time itself slows down near a black hole, a phenomenon known as time dilation. For years, black holes remained invisible, detectable only by their gravitational effects on nearby objects. But in 2019, history was made when the Event Horizon Telescope captured the first ever image of a black hole in the center of galaxy M87. This iconic image confirmed many of the theories scientists had held for decades. As our technology advances, so does our understanding of these cosmic phenomena. From studying gravitational waves caused by colliding black holes to exploring the possibility of quantum gravity within them, black hole research is on the cutting edge of astrophysics. One day, we may even understand what happens inside the singularity itself. Could it lead to another universe, as some scientists speculate, or unlock the secrets of quantum mechanics? For now, black holes remain one of the greatest cosmic mysteries, and their study promises to reshape our understanding of the universe. Thanks for joining me on this journey into the cosmos. If you want to learn more about space and the universe, don't forget to like, subscribe, and hit the notification bell.